Let us consider three capacitors C1, C2 and C3 are connected in series with an external source of potential V. In order to explain this, what I'm going to do, I'm going to consider three capacitors C1, C2 and C3 connected in series and the external voltage is V. So let's use this information to draw the figure, and if we do that, we will get a figure something like this, where C1, C2 and C3 are the capacitors connected in series and V is the potential, which is basically the external potential connected to this series. Now, since the capacitors are connected in series, then the potential difference across C1 is V1, across C2 is V2, and across capacitor C3 is V3. So we will write, let the potential difference across C1, C2 and C3 are V1, V2 and V3 respectively. Then we can write V1 is equal to Q over C1, V2 is equal to Q over C2, and V3 is equal to Q over C3. As we know, the total potential is V due to the battery, and that V is equal to V1 plus V2 plus V3, because this V is equal to sum of all these potentials. So V is equal to V1 plus V2 plus V3, which is over here. Now let's substitute the value of V1, V2 and V3 in this equation from here, and if we do that, we will write V is equal to Q over C1 plus Q over C2 plus Q over C3. Now, as we can see, Q is common, so we can take Q common, and if we do that, we will write V is equal to Q. Inside the bracket, we have 1 over C1 plus 1 over C2 plus 1 over C3. Let the total capacitance across the circuit is C, which is given as C is equal to Q over V. Let's substitute the value of V is equal to Q inside the bracket 1 over C1 plus 1 over C2 plus 1 over C3 in this equation. And if we do that, we will write C is equal to Q over V, which is this term right here. Now, as you can see, this Q is cancelled out because it's common term. And if we do that, we have C is equal to 1 over C1 plus 1 over C2 plus 1 over C3. If we simplify further, we will get 1 over C is equal to 1 over C1 plus 1 over C2 plus 1 over C3. And this is how we will find the series combination of capacitors.